Hi, my name is Barbara Friesen, and today I'm going to be going over the partition method here that I wrote for a quick sort class. So right here is where I have my partition method. Firstly, I'm going to explain a little bit what a partition method is supposed to do. For this case, it's supposed to choose a pivot and then move everything that is less than the pivot to one side of the array that is given, and then everything that is larger than the pivot to the other side. So first here I have my comparable pivot, which leaving it as comparable, even though we are dealing with integers in this example, will allow it to be used for other things in the future as well. And so I'm just arbitrarily choosing the one in the middle of the array that is given over when calling my partition method. So first things you want to do is you want to swap your pivot here with the one of the last element of your array. So therefore you don't have to create a new array in order to do the sorting, and you can just do an in-place sort. So then I'll have I be my placeholder for which index that I am at. So initiate that at first, and then it'll go to last. You don't want to initiate it at 0, because if you're doing the higher set of the arrays, it's not going to be starting at 0, and you'll mess up your sort. So it'll do a compare here with the item at the index to my pivot. And what compare does, if it is less than, then it'll have less than 0 as a value. If it's larger than, it'll be greater than 0. And if it's equal, it'll equal 0. All we care about is if it is less than 0. So if it is less than 0, we're going to swap the reference that it's pointing to right here with the current pivot index, and then following it by increasing the pivot index. So this will go for the whole array size except for the last one. As you can see, it has to be less than last. This is because our pivot is stored in the last index of the array. After all that is sorted, from lower or higher, you want to swap the references back into place so the index is not at the end anymore, and then you'll return the p-index for the recursion to continue. So I'll just show you how this worked out here, run this code. So here's what we started with, 20 in descending order, and after our sort, we have 1 to 20 in ascending order. So that pretty much just sums up how you would write the partition method for a quicksort class. Thank you for watching.